Today's video is going to be on crossing out. So crossing out is fractions, but we use it quite a bit in our units in trying to figure out dimensional analysis. So it's really important that you understand the concept of it. So at the basis of it, we have to remember that multiplication, the order does not matter. So 2 times 3 times 8 is the same thing as saying 2 times 8 times 3. My final product is not going to depend on which order I multiply these numbers. It's also going to include understanding the concept of reducing fractions. So 4/6 can be reduced to 2/3 because I can divide both of them by a common factor, a number that is a factor of both of them, in this case 2. So I divide 4 by 2 to get 2, and 6 by 2 to get 3. These are the two basic concepts that we use when we do crossing out and dimensional analysis. So it's not magic math, it's just fractions. So here's an example, crossing out units, where the units can cross out just like variables or numbers. So if I'm converting 3 seconds and I'm multiplying it by a conversion factor of 28 meters per second, I can reorder this and I can move these units of seconds over here. So it's 3 seconds divided by seconds. And I'm left with 1 over here. So remember that any whole number is understood to be over 1. So I can cross out my seconds because units, just like variables or numbers, can cross out. So my seconds cancel out. And I'm left with 3 times 28 meters over 1, which is 84 meters. So example 2, crossing out over a distance. So I have 4 numbers, fractions, that I'm multiplying by one another, and all conversion factors are fractions. 2/5 times 8/3 times 20 21st times 27 28. And I can rearrange this, and I've color-coded to show you. So I've moved the 20 over here, moved the 28 over here, the 3 over here, and the 21 and the 2 over here. So I've rearranged them in a way that then enables me to reduce the fraction. So 20 over 5 reduces to 4 over 1. 8 over 28 reduces to 2 over 7 because 4 goes into both of them. 27 over 3 reduces to 9 over 1. And 2 over 21 doesn't reduce. So sometimes they don't reduce. But what I can do then is rearrange this pair right here so that it becomes 9 over 21 and 2 over 1. So 9 over 21, 3 goes into both of them, so 9 over 21 can reduce to 3/7. So now what I can then do is multiply and divide numbers that are much easier to multiply because they are smaller numbers. So 4 times 2 is 8, times 3 is 24, times 2 is 48, and then 7 times 7 is 49. Or, rather than rearranging them, recognizing that anytime you have any numerator or denominator combinations, whether they're far apart or close to each other, they can be canceled out. So I've kept the numbers as they were, but I'm looking for numerator-denominator combinations, so things that are in the top and the bottom that I can cross out. For example, my 8 and my 28, I can reduce to 2 over 7. And my 20 over 5 can reduce to 4 over 1. My 27 over 21 can reduce to 3 over 7. And actually I did before that. My 27 over 3 reduced to 9 over 1, and then I reduced the 9 over 21 to 3 over 7. And I get 48/49. So putting it all together, I can think about crossing out units and crossing out numbers. And so if I'm going to cross out my units, I will say, all right, I have numerator-denominator combinations. I can cross out my seconds, and I can cross out my meters. So all that I will be left with at my units will be dollars, and then I will find numbers to cross out. So 8 goes into 24 3 times, and 3 goes into 15 5 times. Nothing else can cross out, but now 3 times 2 over 5 is much easier to deal with. So I have 6/5, but remember that we can't have anything be a fraction in science. It's got to be converted to a decimal. So that will be $1.20. Now, one thing that's important to know, if you decide to use your calculator, that you always have to remember your PEMDAS rules. So if I were to do something like up here, 2 times 2 times 4 times 3 divided by 7, if I then did, so I wanted to do this, 2 times 2 times 4 times 3 divided by 7 times 7, if I don't put parentheses around this 7 times 7, what it will do is it will divide this value by 7 and then multiply it by 7 at the end, which kind of undoes my work. So you have to remember your PEMDAS rules and work with your calculator, not against it.